Okay, what we have now is the cast nut, pre-machined, 2 operations, one in the manual lathe, turning between centres to rough turn a centre, op 2 to create datum and face. Now we're going to carry on with the operation to face, bore, thread, and then clean up the section, which is approximately 65mm deep, and within that section we're going to be putting a trapezoidal 28 by 5 pitch 7H thread. This is the setup. I've just run 3 or 4 off, trying to get the feeds and speeds right. We're still getting a little bit of chatter on the final passes of the thread cutting. I've adjusted speeds and feeds 2 to 3 times, and I'm pretty happy that what we've got now is as good as we're going to get. So, machine soft jaws to match the diameter of the datum face, and a fixed steady. Good practice, clean your soft jaws.
Clean your soft jaws and the rollers on steady.
What I've done just for illustration is I've eased off the rollers on the steady. And now what I'm going to do is raise those rollers up. And the best way that I find to do this is I will run the spindle at a slow speed and have them touch on the work. That way the rollers square up to the work and don't dig in. As you may have heard, I didn't clean that roller quite as well as I thought.
Just until we obtain consistent pressure and then lock it off. That would be really steady. Oil, wheels and bearings.
It's important to lock your steady before you lower your top roller. And then what I normally do, run the job, what are we running there? About 150 RPM. So that's it, that's the job set in the machine. Steady is set, and now we're pretty much ready to run the job. Just before we run it, give the ways a bit of a wipe. Just to see our tooling setup, we've got a combined rougher finishing tool here. We're going to be using this to clean the face. Once that's done, boring bar to get our internal dimension, and then there's our threading tool. As you can probably see, we've had to grind a good 3mm off the diameter of that threading tool because it doesn't actually fit. Once it retracted into the internal hole, it would have collided. So, glasses on. Cycle start. What I'm going to do once this job's finished is, if you can see this face of the fixed steady, I'm going to put an apron on there, because what I'm finding is happening is the chips that are being created on this facing pass, mainly the first facing pass, are flicking up and getting trapped between the job and the roller. Don't seem to be having any issues after that first pass. You heard one there, those little grouching sounds. That's the sound of a little piece of cast iron getting trapped between the job and the steady.
We're finding we're having to take quite a lot off the face of these. Due to the geometry of the raw casting. We're also finding that a lot of them have got a little blowhole right at the end. As you can see, clearance is clearance, as they say. That's the threading tool.
And now the tool is just coming over, doing a finishing pass and putting a slight chamfer on the end. Boring bar.
Just playing with the feed, see if that makes any difference. But no, it doesn't. The reason that's making that whine is because the casting bore of this part is quite egg-shaped. So in this pass, it's only just about clearing the hardened skin. When it hits that hardened skin, it makes that whining sound. Putting a lead on for the trapezoidal thread.
We're taking 0.1 cuts here, so 0.2 off the diameter.
And just here, as it goes in, where it hits a couple of hard spots in the material. I can't say that's been very helpful for the tool life, if I'm honest. we're averaging about 8 parts per tick. Once we get in about 80% of the depth, she'll start to chatter. Again, I've tried with the feeds and speeds. We're doing a leading edge type of cut here, so that tip is effectively working that forward edge of the thread. But as soon as that tip starts to get encapsulated by the thread, she does start to chatter. Also rolls a big burr over. And at this pattern, on the retract, you can hear the tip hit the burr. You'll see the coolant starting to dance now all over the job. We're doing spring passes now. And this is really where the chatter comes. Ideally, we'd like to change the feed, but with this machine, once the threading cycle started, you can't change the feed rate.
But believe it or not, the quality of that thread is not too bad. Last up, we've got a boring bar being pushed in to knock off the burr that's been rolled up on the top of the leading edge of that thread.
So it just cleans up the minor diameter.
And that's it. All to do now is to get the turret out of the way and inspect the job. So here's our, effectively it's a go gauge. It's a sample of the male part that we've inspected. The male part is within the limits of a 7/8 thread. Effectively what we've done is we are making the internal thread to suit, because if we were to look at the parameters that are set on the program, the major diameter in there is far greater than the specification will call for. The reason for that is basically push off of the tool. However, proof is in the pudding, as they say. A bit tight at the end. However, what I'm going to do now is so here's our batch of lead screws. Now, what I'm going to do, there's a small tight spot right at the end of the internal thread. Now I expect that's because the burr, as the thread tapers out, is binding on the sample. So what I'm going to do now is just a little bit of oil on this thread. Start the spindle at a low RPM. just see if she'll roll in. Obviously, no sleeves. Yeah. So, as you can see, the thread's going through. There was a burr at the end. That's the thread all the way out the back of the job now. And let's make the machine do the work.
Keeping both arms out. Very, very light pressure on the screw. What you don't want to do is have it snap. If it snaps, just let it go.
There it is. Now he's gone through, I'm going to run our standard back through. There she goes. Standard goes in there, lovely. That lead screw knocked the burr off. There it is.